three-dimensional vectors, that is x1, x2, so on xn. Then we can obtain a distances between these objects phi n cross n matrix is a symmetric matrix D. So this D will be written as capital D is equals to the diagonal matrix will always be zero. This is D12, this is row 1, 2, 1, top to D1n, and this is D21, D2n, and if we take D1, and this is how the distance between the n objects that is taken from the n cross n matrix are written. This is nothing but Dij, which is the distance. The formula is summation h is equals to 1 to b xij minus xjh whole square whole to the power of 1. This is nothing but the Euclidean distance. And we can also express this Dij in another way, that is mod summation h is equals to 1 to b xij minus xj. This is the another way of representing the distance. And now let us take this as equation now. So now we need to transform. This d, the square distances, which is nothing but whatever the Dij we have, we need to square them, and we need to convert this matrix into a similarity matrix. So from the similarity matrix, I extract the eigenvalues, so that from those eigenvalues will give me the geometric representation of higher dimensional data reducing it into lower dimension. So this is what the transformation we have to do. So now the transformation matrix will be E. This can be also called as inner product matrix. And this contains Dij values. This is nothing but Dij is equals to, this is using double centering formula, which is minus 1 by 2 into Dij square minus Di dot square minus D dot j square plus D dot square. This Dij is nothing but the square distance between object I and object j. This Di dot square is 1 by n summation j equals to 1 to n Dij square. This is nothing but the mean square distance from object I to all other objects. Here we are taking I dot. So from object I, the all other objects in this matrix. And Dj dot D dot j square is nothing but 1 by n summation I is equals to 1 to n Dij square. This is nothing but we are calculating the mean square distance from object J to all other objects. And D dot square is nothing but the grand, the distance square of grand. Then we have a question that why we need to transform this distance into similarity matrix. Because we need to calculate the inner product of a centered vectors. Now let us know what is the centered vector and inner product matrix. These centered vectors are nothing but whatever the data that we have, whatever the distance or data we have, we will convert their mean or average to be a 0,0. So that whatever the geometrical representation we are finding in lower dimension, that will be accurate. I will give you an example how we can calculate the centered vectors. The example can be, let us take x1, that will be 20. are the original vectors. And let us think that it is a height and this is a height. So these are the original vectors. First we need to find out the mean here. So the mean of height, this will be 20 plus 40, which is 60. 60 divided by 2 is 30. For x. And mean of x2, that is 40. It is also 30. So after calculating the mean, we need to subtract this matrix, whatever they can become from this original matrix. So 20, 30 minus 30 comma 30. So this 20 minus 30, which is minus 10, and 30 minus 30 is equal to 0. And for the same, for this 40 minus 30, which is 10, and 20 minus 30, which is minus 10. These are nothing but whatever that we have obtained, these are nothing but the center vectors. And I will give you another example. Why we are doing center vectors? Because we have a given that is 1 on 1 comma 11, 1 that is 100 comma 10, and we have Q1 that is 1 comma 1, and Q2 that is 2 comma 1. And if we calculate the distance between P1 and P2, that will be root. You can do it. Let's do under root x minus x plus 5 minus 5. And the distance between Q1 and Q2 is also root. If you think that they are equal, these distances are equal. But when you see the absolute value, is 101 and 100, these are far away from the origin. And these values are nearest to the origin. If you give the same data to the calculate for the inner products, whatever the geometrical representation that we are doing, that will be inaccurate. So that's why we need to make sure that whatever the data set we have, we need to convert their means. That is, we have to convert their means sit on the origin, so that we will get the accurate geometrical representation. This is why we are doing the center vectors. And now let us know what is inner product. Inner product is nothing but the dot product, which will be using algebra. This we can calculate whatever the center data that we got. Minus 10 comma 0.
10 comma minus 10.
10 comma
minus 10.
These are the center data we have. We need to multiply these both. Then after multiplying these both, we need to sum. In this way, we will get the inner product. This is minus 10 into 10. That will be minus 10. And 0 into minus 10 is 0. So when we add, we will get the inner product as minus 100. This minus 100 is nothing but whenever we get the inner product as minus 100, which is nothing but the larger negative numbers. The larger negative number indicates that the whatever the center vectors that we have taken, they are very distant. They are in the opposite direction. And if it is positive, let us say 100. If it is 100, then it will represent that the two vectors, the two center vectors, are very close to each other, very similar. And if it is 0, we have the diagonal matrix as 0, which is nothing but there is no correlation. They are perpendicular to each other 90 degrees. So this is why we do the inner product. I hope this is clear about why we will do the center vectors and the inner product. And I have said the transformed matrix B that will contain B or J elements. This B is nothing but the inner product matrix. And we take a B has positive semi-determinant. And if you see in your 4 point, if D is a Euclidean distance, then the B must be positive semi-determinant. So now let us learn what is a positive semi-determinant and why the statement is different opinion. B is distance, then it must imply B is positive semi-determinant. If this is semi-determinant, then it should imply that the distance is the Euclidean distance. Now let us see what is positive zero vector, which is Z, which represents Z D Z transpose is greater than or equals to 0. And this D is the inner product matrix. So that if it is greater than or equals to 0, the eigenvalues will not be negative. They will always be positive. This is positive 75. And whatever the distances we have taken here, the equation 1, this is the Euclidean distance, which is nothing but whatever the original distances we have, these are coming from the true Euclidean, which is nothing but greater than or equals to 0. So the low distance will be in a negative. So the eigenvalues, if we extract the eigenvalues from it, then it should be positive. So that's why we consider the B matrix as positive symmetry. So I hope it is clear. If D is Euclidean distance, then B must be positive. If it is not positive definite, then it seems that the D is not coming from the true Euclidean. After extracting the B matrix, we need to extract the characteristic vectors from it. These are L1, L2, and so on, Lr. And these are associated with the vectors V1, V2, so on, Dr. From the V matrix. And we normalize these vectors, that is Dj transpose Dj, which is equals to Lj, where J is equals to 1, 2, 3, so on, R. Lj transpose Lj, which is equals to 0. Extract the B, the characteristic vectors, we will form the column vector, that is M cross R matrix, which will be B is equals to D1, D2, so on, Dr. W1 transpose, W2 transpose, and so on, Wn transpose. And if we multiply these four, we will get some matrix, which is B matrix. So, whatever the rows that are there, which are nothing but the coordinates of n objects. The rows that we have, which are nothing but the coordinates of n objects. The coordinate, which is nothing but x, y. And if the coordinates are entirely lying in our r direction, whatever the r that we have taken, if they are entirely lying in this r dimension, then the distance estimate, whatever the similarity matrix that I have said, which will be Dij hat is equals to Wi minus Wj transpose into Wi minus Wj whole to the power of 1 by 2. And this is nothing but which is equals to the equation 1, which means whatever the predicted estimate that we have done, which will be equal to this one, so that it can able to capture the original variances or original distance. And if we take r is equals to 1, 2 or 3 and 3, we can plot the r dimensional space or r coordinates in our objects. This will make sure that it will identify the relationship between the objects, how they are similar and how they are dissimilar. And if you see the coordinate, whatever the x, y that I have said, if you do the sum of x plus y, that will be always 0. And the coordinates of n objects, the centroid, which is nothing but the mean, will always be the origin, 0, 0. That we have considered the center. Why we are doing the center vector? This is the reason why we are doing the center vectors. U1 is equals to D plus Y plus H. This E is nothing but the R cross R orthogonal matrix, and this H is R cross N vector of constants. And this is how we will convert our similarity matrix